Hello and welcome back to the Project Hercules Diaries, filmed from the stool of contemplation, looking at the front wheel. Doesn't that look amazing? If we could get away without having a front disc and just have two rear discs, one on each side, how cool would that be? Unfortunately, the MOT man in the UK does not like a single wheel braked, so it's going to have to be front discs on the front as well. Now, waiting for bits, waiting for parts, so the replacement disc, caliper, probably going to go with the twin pot on the front now, foot pegs, a few of the bits and bats. So while I'm waiting for those parts, it's time to start thinking about how you're going to start the bike, because if you've been on the channel for a while, you'll see that this Dynastart, you'll know, is not really man enough or lady enough for the job of starting the engine. In the past, a load of people have said, oh, just put this starter motor on, just put that starter motor on, that starts a 4-litre V8. Well, yes, it might do, but it still won't necessarily start this, because when you think about it, a 4-litre V8, each of the 8 cylinders is only 500cc, and you're only compressing one or maybe two of those at a time, so your starter motor only needs to squish a 500cc. Same with the 3-litre V6. This is nearly 3 litres in a single cylinder. It's 2.8 give or take, so that means you've got to compress that all in one go, and that's quite a different situation. If this was a V6, it would be not quite 17 litres, and if this was a V8, it would be just over 22 litres. God, how's that for maths on a Saturday morning? 16.8 and 22.4 respectively, which gives you an indication. So this starter motor, this Dynastart, although it looks really neat, isn't quite up to the job, but that's only half the story. The other half of the story is our reduction drive here. Now, the most reduction we can get is about 1 to 4. So on a normal car with a conventional starter motor on the ring gear, it's probably between 14 and 20 to 1, sort of average figures. So there's a lot more reduction on a standard starter motor for a standard car, and that means that the starter motor is trying to turn the engine over faster, which is good, but it also means that there's less mechanical advantage from the gear ratio. So we've got a few problems to fix. We need more power in the starter motor, and we've already seen that a standard starter motor in place of this at 2.5 kilowatts still isn't enough, because the gear reduction isn't sufficient. So we need more power in the starter motor, and we need more reduction. So that's going to be tricky, because the smallest sprocket we can fit on here we've already had on here, and putting a larger sprocket down here is quite the job, and then the chain clearance becomes a bit of an issue. So we have a plan B. There's always a plan B, and it's great that when you start to do a different job, your head goes somewhere else, and you wake up one morning with the answer to a problem that you weren't even thinking about. This is the back of the sprocket, and that's a nice boss, and there's quite a gap here. So what we're planning to do is to buy a toothed gear that goes on this part of the sprocket that's about that size, fit another starter motor on the top, so we'll get about a 5 to 1 reduction from a conventional car starter motor with a Bendix to drive this sprocket and drive the Dynastart, and then get a further up to 4 to 1 reduction here. So that can get us between 10 and 20 to 1, which is in the right ballpark. A 2.5 kilowatt starter motor on top of the Dynastart. If we wanted to, we could bridge them together, so we'd get another 900 watts of starting power if we needed it, and that should do the job. So to do that, you're going to need another starter motor, of course, which is here. It's here in the Bridgeport mill. So I've purchased a starter motor. The guys at I forgot the name of the company. Anyway, some company were very useful. I'm not sponsored, so it doesn't matter. So yes, this is the starter motor sitting, pointing nose up into the air. What I'm doing here, I'm just going to mill off a bit of this flange, and I'm going to cut a radius into there, so it sits lower on top of the Dynastart. And I'm going to match the radius of the Dynastart itself, so that there's a nice fit between the two of them. And then I can measure centres of the two shafts and buy a gear that's the right size. So I've written a little program Just a little bit of G-code that cuts an arc. So the diameter of this circle, if it was a full circle, is the same as the diameter of the Dynastart. And I'm just going to push the cutting tool into the edge of the starter motor flange so the two sit nicely on each other. And what I always do here, I do a dry run so the tool is just above the height of the starter motor, and it's set so it doesn't actually make contact. Nothing's running, so I'm not likely to catch my fingers or anything. And if I run the program, you'll see that the cutting tool makes a nice arc, and everything seems about right. So here we go. This is the program that I've written. It'll just bring the cutting tool in on a nice arc around here in the same radius and diameter of the Dynastart. Obviously I will put something across here so the chips don't all go into the gear of the starter motor. You can sort of see it coming in there. And then at the end of the program, it's just going around that arc. So at the end of the program, we'll have a nice arc. This flange will be taken right back down to there, and it'll sit nicely on top of the Dynastart. Then we can work out what gears we need and take it from there. So that's the job for today. That's probably all I'm going to do today, because as you can almost see, it's sunny outside. And it's going to be a cracker of a weekend, so there's probably a fair bit of bike riding to be done as well. So that's it for the morning. As usual, thank you for watching. More updates will follow.